So today, let's talk about being an architect, not with brick and mortar, but with data. We're going to dive into the tools that build the absolute foundation of every single database out there, Data Definition Language, or DDL for short. All right, let's get building.
Before we can even think about finding a customer or calculating a sale, we have to ask a really basic question. Where is all this data supposed to live? It can't just float around in the digital ether, right?
And that's exactly what we're talking about today. Data needs a home. And not just any home, but a well-designed, structured, and reliable place to exist. DDL, well, that's both your architectural blueprint and your set of power tools for building that home from scratch.
Okay, so let's start with that blueprint. What in the world is DDL really, and how is it different from all the other ways we talk to our databases? Let's break it down.
It is absolutely crucial to get this distinction. Think of it this way. DDL is the architect. It's the one who builds the classroom, puts in the walls, and installs the whiteboard. It defines the structure. DML, on the other hand, is for everything that happens inside that classroom. It's for writing on the board, putting books on the shelf. It's all about manipulating the data within the structure that DDL already built. So the DDL toolkit is actually pretty simple and powerful. It really boils down to three main commands. Create, which is for building brand new things. Alter, for when you need to change or modify what's already there. And drop, which is your demolition tool for getting rid of structures completely.
All right, let's get our hands dirty and move to the construction site. How do we actually use that first tool, Create, to pour the foundation for our data's new home?
Everything, and I mean everything, starts with Create Database. This is the big one. It's the top-level container for your entire project. Using our analogy, this is like you just went out and bought a brand new, totally empty cupboard. It's the very first piece of the puzzle.
Now, an empty cupboard isn't very useful, is it? It's just a big box. That's where schemas come in. Using Create Schema is like putting neatly labeled folders inside that cupboard. You could have one for human resources and another for sales, keeping everything tidy and making sure you don't accidentally name two different things the same.
And finally, we get to the place where the data will actually live, the table. Create Table is like putting notebooks inside those folders. This is where you define your columns, like a student ID or a first name, and decide exactly what kind of information goes in them. So you'd say something like, Create Table Students, Student ID, int, first name, varchar 50. Now we have a structure. But how do we make sure it's a good structure?
See, just building the structure isn't enough. A house without any rules is just chaos. We need to enforce some laws to make sure our data is reliable and that it actually makes sense. In the database world, we call these rules constraints.
And this is a point I really want to drive home. Without rules, you can't trust your data. It's that simple. Constraints are like the building codes for our data house. They make sure that what you put in is valid, so what you get out is dependable.
The very first rule is about choosing the right building materials. For us, that means picking the right data type for every single column. You use int for whole numbers, varchar for text, date for, well, you get the idea. And here's a pro tip. Always choose the smallest data type that can correctly hold your data. It makes a huge difference for performance down the road.
Now, if there's one rule you absolutely cannot forget, it's the primary key. Every table needs one, period. It's the unique identifier for every single row. The analogy is perfect. It's like a roll call number for students. No two students can have the same number, and every single student has to have one. It's non-negotiable.
Okay, next up, foreign keys. These are what let us build bridges between our tables. A foreign key in, say, an enrollments table will point back to the primary key in the students table. What does this do? It makes it physically impossible to enroll a student that doesn't exist. No more orphan data. It keeps everything connected and logical.
But what if you need a custom rule, something specific to your business? That is exactly what check constraints are for. You can literally define a rule like the age must be greater than or equal to 5, and the database itself will reject any data that breaks that rule. It's a super simple but really powerful way to enforce common sense at the most basic level.
So, we've built our structure, we've set all the rules. But here's the reality. Business needs change. The blueprint you start with is almost never the one you end with. And that brings us to the tools for remodeling and sometimes for demolition.
The alter command is your best friend when it comes to renovation. Realize you forgot to add an email column? No problem. Just alter table to add it. Need to make a column bigger to handle more data? Alter can do that too. It's what allows your database structure to evolve as your application grows.
But, and this is a huge but, you have to be incredibly careful. On a table with millions or even billions of rows, running an alter command can be a massive, expensive operation. It can lock that table, meaning nobody can use it, sometimes for hours. These kinds of renovations have to be planned with military precision. That's why pros plan these things for low traffic times or use special tools to do it without locking everyone out. Planning is not optional.
And then, we have the demolition ball, the drop command. This is what you use when you need to remove something, a table, a schema, even the whole database, completely and permanently.
And let me be absolutely 100% clear on this. Drop is irreversible. There is no undo button. There is no trash can to pull it out of. The second you run that command, unless you have a backup, that structure and every single piece of data inside it is gone. Forever. You have to treat this command with the utmost respect and caution.
Okay, as we bring this all home, let's just step back and think about the huge power and the huge responsibility that comes with being a data architect. The choices you make with DDL will ripple out for years to come.
You see the same architectural mistakes pop up over and over again. People choosing the wrong data types, completely forgetting to add constraints like a primary key, accidentally dropping the production user table instead of the test one, or running a massive alter right in the middle of the business day. Every one of these can cause data corruption, terrible performance, or even bring the whole system down.
So if there's one thing you take away from all this, let it be this. Good DDL is not just about typing commands. It is about thoughtful, careful design. Your initial design literally defines what correct data even means. It sets the performance ceiling for your entire application, and man, is it difficult and expensive to change later on.
I'll leave you with this final thought, a saying that really sums it all up. A bad query might slow your system down for a few minutes, but bad DDL, a poorly designed data structure, that can break your entire system in ways you can't even imagine. So before you write a single line of code, remember the architect's golden rule: design first. Now go build something amazing.